So this was one of the approaches where you start from the query term, you generate all the strings at a particular edit distance from this, within a particular edit distance from this query, and then you look up which of those strings are found in the lexicon or the dictionary, and you rank the um, each of those candidates based on what the edit distance is, and secondarily what the uh, collection frequency is, and then you decide to present one or more of those corrected spellings. The problem with this approach is that, even to calculate the number of strings that are at a distance of 2 from the query term, I have to do a huge number of, I have to generate a huge number of strings. Okay, what is the number of strings that are at a distance of 2 from a given query term? That means I have to do so let's assume we are working with the first definition of edit distance where all three operations have a cost of 1. Even for this simplified edit distance measure, we still have to uh, generate all strings that are at a distance of less than or equal to 2. That means I have to modify this given query term in every possible way that I can modify. Right? So I have to do 2 modifications to my query term, but those 2 modifications can be any pair of modifications. So I have to look at all possible pairs of modifications to the query term, and that will give me the set of strings to work with. And that could exponentially explode as I increase the size of this threshold. If I increase it from 2 to 3, then it's going to increase exponentially. A more intuitive way to calculate the corrected spellings is in the following way. You take the query term, and instead of generating all strings at a particular distance from the query term, you just compute the edit distance of that query from every term in the dictionary. Okay, so I take the query term and I compute its edit distance to every term in the dictionary, and then I do the same thing that I was doing earlier, which is to look at the collection frequency of each of these candidates. So firstly, the terms that have an edit distance of 1 from the query term, those will be the best candidates. And then among those best candidates, I'll look at the collection frequencies and decide which of them is the most likely. But this also is pretty expensive and slow because I have to run that dynamic programming algorithm for every term in the dictionary. Okay, so this is also impractical. Do you see the difference between these two approaches? In the first approach, we are taking the query term, generating every possible string at a distance less than or equal to some threshold, and then checking which of those alternatives is present in the dictionary. And then taking the candidate terms and looking at their collection frequencies and then deciding which is the best suggestion. Here, we are taking the query term and we are computing its edit distance to every term in the dictionary. Then we take the terms which have the least edit distance from the query and then sort them according to their collection frequencies and present the best ones as the suggestion. Both are expensive. Okay, so both are impractical. So what we're going to try to do now is we're going to try to cut down the size of these the number of candidate terms that we have. Instead of computing the edit distance of the query from every word in the dictionary, let's first choose a small but good set of candidate terms from the dictionary and compute the edit distance only to those terms, not to every term in the dictionary. And that brings us to this third measure of distance between two words, which is called an Ngram overlap. and we're going to see how to use our old Ngram index or Kgram index, which we talked about when discussing wildcard search, to now do spelling correction. So here is how we use the Kgram index. Okay, we sometimes call it an Ngram index, sometimes we call it a Kgram index. It's the same thing. So recall what was a Kgram? A Kgram was just a consecutive a consecutive sequence of K characters from a given query term. So if I have a query term like hello, the 3 grams in this query term are HEL, ELL, and LLO. Now, suppose we enumerate all the K grams or all the N grams in the query string as well as for every word in the dictionary. We could use the K-gram index that we built a couple of classes ago to retrieve all the dictionary terms. Okay, again, remember that we had two dictionaries now. We have a K-gram index which has its own dictionary and its own postings list, and we have the standard inverted index. Okay, which has terms in the dictionary, and in the postings list you have the documents. Now we could use this K-gram index to retrieve all the terms in the dictionary of the standard inverted index that have a good overlap with the query term. And how do we define a good overlap? Suppose most of the K-grams in that lexicon term match the K-grams of the query term. In that case, we would call it a good overlap. So one of the ways we could decide that something is a good overlap is to come up with a threshold. We can say that if there are 5 trigrams that match between the query term and a term in the dictionary, then that particular term in the dictionary is a good overlap with the query term, and so it's a good candidate term for to suggest as uh, a spelling correction. Is that clear? Any questions on this? I'm going to describe this approach in more detail, but the high level idea.
No questions, sir.
Okay. So here's an example. Let's work with a trigram index. Okay, so now suppose there is a document, not a document, sorry. Suppose there is a term in the standard inverted index. So if we look at the dictionary of the standard inverted index, let's say we look at a term like November. Now in the Kgram index, we are going to have entries for NOV, OVE, VEM, EMB, MBE, and BER. Now in the Kgram index that we talked about a couple of classes ago, we also had this special character dollar at the beginning and at the end. So I mean that can also be done, but let's assume that we are not doing that to simplify things here. Let's just focus on these actual 3 grams. So there will be an in the dictionary of the Kgram index, we will have this trigram called NOV, and the postings list for NOV will contain November. It will also contain any other term which contains that trigram. Okay, that was how we defined the Kgram index. Similarly, VEM will be present in the dictionary of the Kgram index, and it will contain all the terms that have this trigram in it, which includes November, but it could also include other terms. Now we could similarly take the query and split it into its constituent trigrams. So these are the trigrams of December. Now how many trigrams in the query overlap with the trigrams in this particular uh, term in the lexicon? There are 3 that overlap out of a total of 6. So as I said, we could define a threshold as uh, say 3 matching trigrams. So anytime there is an overlap of more than a 3 between the query term and a term in the lexicon, we could decide this is a good match. But alternately, can you think of a reason why this sort of a thresholding would not be a good choice? To say that, well, anytime there is an overlap of more than 3 trigrams, more than or equal to 3, that's a good overlap. Is this a good way to define a good overlap? Think of a very long query term and think of a very long lexicon term. And let's say that 2 words are actually not related. Just by chance, you could have 3 matching trigrams between those, right? If you have short words, then the likelihood of matching trigrams just by chance is pretty small. But if you have 2 very long words, it could happen that there could be, 2 or 3 trigrams that could be common to those 2 words, even though those words are not really, spelling variants of one another. Or it may be very unlikely that somebody could mistype one word for another, but still those 2 words could have a sufficient overlap. So defining an overlap in an absolute sense, saying that anytime there is more than 3 common trigrams, that is a good overlap. There's some problem with defining a good overlap in this particular way. So let's turn this into a normalized measure of overlap where we also keep into account the fact that if there are very long terms, if the query is very long and the lexicon term is very long, we don't want uh, uh, we don't want to define a good overlap in an absolute sense for such cases. So here's another measure of overlap called the Jaccard coefficient. And this is an important measure. It's something we are going to use again and again in future lectures. So make sure that you understand what this is. The idea is pretty simple. The Jaccard coefficient is defined on 2 general sets, X and Y. For a moment, forget about trigrams. Just think of a set X and a set Y having some elements. The Jaccard coefficient of these 2 sets is defined to be the size of the intersection of the 2 sets. Okay, that means the number of elements in this intersection divided by the total number of elements in the 2 sets. That is the size of their union. Okay, so it's the size of X intersection Y divided by the size of X union Y. Now what happens if X and Y exactly what happens if X and Y are the same set? Okay, in that case every element of X is an element of Y and vice versa. So X intersection Y would be nothing but X or Y because they are the same set, and likewise X union Y would also be X. So the Jaccard coefficient here would be 1. And what happens if X and Y are totally disjoint? There are no elements in common, so the numerator would be 0 because X intersection Y would just be the empty set. So this would be 0 divided by some finite number, which would be 0. So when there is absolutely no overlap between the two sets, the Jaccard coefficient is 0. And when there is complete overlap, when the two sets are actually the same, the Jaccard coefficient is 1. And in general, if there is a partial overlap, as in this diagram, the Jaccard coefficient will be some number between 0 and 1. Because it will be the number of elements in this region divided by the total number of elements here, which will be definitely larger than the number of elements in this region. And note that the sets x and y don't have to be of the same size. Right? This is a general coefficient. The two sets don't have to be of the same size. So we could decide that if the Jaccard coefficient between the two sets is more than 0.8, that is when we are going to call the overlap as a good overlap. Okay, and of course there's some subjectivity in this threshold, but we could define a good overlap in a way like this. We could say that if the Jaccard coefficient is close to 1, approximately close to 1, then it's a good overlap. So what we are going to do is we are going to use this particular Jaccard coefficient to decide whether or not the query and the lexicon term have a good overlap. So the set X is going to be the set of trigrams in the query, and the set Y is going to be the set of trigrams in the lexicon term. And we're going to compute the Jaccard coefficient between these two sets. Okay, and if the Jaccard coefficient ends up being approximately close to 1, then we are going to say that the query and the lexicon term have a good overlap. And note that if somebody does a spelling error, okay, let's say while typing a particular term, you introduce a spelling error, it's likely that most of the k-grams are going to remain unchanged. Only the k-grams that are involved in that spelling error, those will be affected. So if we define our threshold in such a way that it's relatively close to 1, then anytime the Jaccard coefficient is more than that threshold, we will say that the particular lexicon term is a good candidate for spelling suggestion. Any questions about this? I'm going to show you how exactly we are going to implement this, but in terms of what we are trying to do conceptually, are there any questions?
Excuse me, sir.
Yeah.
Sir, regarding the last slide,
Yeah.
the trigrams previous to
Okay.
that. Yeah. Sir, if a query is December and the text is remember, will it match? Because the last three trigrams will obviously match, right? Will it be a good pair?
Remember and December.
Yeah.
Okay, so this is the part that is common, right? So remember, what are the trigrams in remember? REM, EME, MEM, EMB, MBE, and BER. Now these three, EMB, MBE, and BER, are found in the query term. Are trigrams found in the query as well. What about REM? REM is not found in the query. EME is not found here. And MEM is not found here. So the size of X intersection Y and the size of X union Y will be 3 plus 3 plus 3.
9.
9.
Yeah, 50.3. No,
So,
0.25%.
so the Jaccard coefficient is going to be 3 by 9, which is quite small.
Okay.
And that's reasonable, because it's very unlikely that somebody is going to mistype December as remember. Right? So just as it's unlikely that somebody is going to mistype December as November.
Yeah.
These two terms also have a Jaccard coefficient of 1 by 3.
Okay. And sir, one more question.
Yeah.
Sir, that cost matrix for the weighted edit distance,
Mm-hmm.
is it applied over here?
No. So we are now talking about a third measure of. Thanks for asking this question, because if you missed this, we are talking about an Ngram overlap here. We are not talking about edit distance here. So forget about edit distance when thinking about this sort of k-gram overlap. We are trying to define an alternative distance measure, and now that distance measure is hard. Okay, so it's edit distance, weighted edit distance, and Jaccard coefficient.